Welcome back to Inquisitive Kids. In this lesson, we're going to be continuing our studying the properties of parallelograms, especially in this lesson, the diagonals of parallelograms. So this is part 2 to our lesson, Properties of Parallelograms. And make sure you pay attention in these 2 lessons because this will play a huge role into understanding the rest of the concepts we will be looking at in this chapter, such as determining parallelograms, the median of medians, and the sum of the interior and exterior angles. All of these build off of your fundamental knowledge of the properties of parallelograms. The 2 learning goals of today is to explore and master the properties of the diagonals of parallelograms, and to use the properties of parallelograms flexibly to reason and calculate. Properties of the diagonals of a parallelogram. We know the properties of angles and sides of a parallelogram from the last lesson. So what are the properties of a parallelogram's diagonals? Well, as shown in parallelogram ABCD, we can connect the diagonals AB, AC, and BD, and let them intersect at point O. So predict, what is the relationship between OA and OC, OB and OD? Pause the video and think about that. Well, the truth is that OA is actually equal to OC and OB is equal to OD in terms of length. But is this conclusion valid? Well, let's find out. The first way we can see to check if this conclusion is valid is to measure. Take out a piece of paper in the shape of a parallelogram, and then use a ruler to test out your prediction. Well, you could always use a ruler and a piece of paper and measure it, but the method is not always accurate. Because what if it's the slightest bit off and you just didn't catch that minuscule difference? So usually this method is not the most accurate method. We can also use proving. As shown, the diagonals of parallelogram ABCD, AC, and BD intersect at point O. So we can prove that OA is equal to OC and OB is equal to OD through logic and reasoning. So here would be our proving process. ABCD is a parallelogram, so AD is equal to BC and AD is parallel to BC. These are some of the properties of parallelograms that we've studied from the last video. Therefore, angles 1 and 2 are equal, and so is angles 3 and 4. From this, we also know that triangle AOD is congruent to triangle COB, using the formula ASA, angle side angle. So OA is equal to OC and OB is equal to OD. And in this process, we first tried to show how triangles AOD and BOC are congruent. And then from that was where we could compare their corresponding sides. Knowledge key point, properties of parallelograms. The diagonals of a parallelogram bisect each other. So how can we apply this property when proving something? Well, here could be how you could use it in a proof. Because the diagonals of parallelogram ABCD intersect at O, therefore we know that OA is equal to OC and OB is equal to OD. Summary. Triangles ABO and CDO are congruent. Triangles AOD and COB are congruent. Triangles ABD and CDB are congruent. Triangles ABC and CDA are congruent. And these 4 triangles have the same area and are both 1/4 of the parallelogram. So if you look at one of these triangles cut out here, this is exactly equal to 1/4 of the entire parallelogram. Out of the pieces of this cake, parallelogram-shaped cake, which ones are larger, which ones are smaller? So here are the pieces split up. In fact, all of them are the same size. Since it's a parallelogram, we know that each of these triangles formed by where the diagonals intersect and each of the vertices, each of these triangles have the same area. Example 1. In parallelogram ABCD, AC and BD intersect at point O. OA is equal to 12 centimeters, OB is equal to 19 centimeters, so we're trying to find the length of AC and BD. Now pause the video and try to solve. Well, you should have gotten 24 centimeters and 38 centimeters for your answer. We know this. Let's solve this together. We can first label OA 12 centimeters and OB 19 centimeters. Since we know that these two line segments are the same and these two are the same, we can just double 12 and double 19, which gives us respectively 24 and 38. Now there are two variations of this problem. Step up 1. Parallelogram ABCD, AC is equal to 24 centimeters and BD is equal to 38 centimeters and AD is equal to 28 centimeters. Therefore, what is the perimeter of triangle OBC? And here's the second variation. In this shape, parallelogram ABCD, AB is equal to 20 centimeters, AD is equal to 28 centimeters. Therefore, triangles AOD and triangles AOD and ABO have a difference of blank centimeters in their perimeters. Now pause the video and use the same properties to help you solve. The answers to these two problems should have been 58 centimeters and 8 centimeters. Here's how you could have solved it. AC is equal to 24 centimeters, which means that these are respectively 12, since we divide 24 in the middle. Now we split 38 in half, so we have 19 here and 19 here. We know that AD is 28 centimeters, but since this is a parallelogram, we know the opposite sides are equal in length, which means that BC is 28 centimeters long as well. Now that we have all of the sides of this triangle here, OBC, we can add them up and that'll give us 59. As shown in parallelogram ABCD, diagonals AC and BD arrive at point O, so they meet at point O. AB is perpendicular to AC. AB is equal to 3 and AD is equal to 5, so find the length of BD. Well, here's our solution. Since ABCD is a parallelogram, we know that BC and AD both are equal to 5. And because AB is perpendicular to AC, we know that triangle ABC is a right triangle. Now using the Pythagorean theorem, we know that AO is equal to 1/2 of AC, which is equal to 2. So BD is equal to 2 times the square root of 13. Example 3. The diagonals of parallelogram ABCD, AC, and BD intersect at point O. Draw a straight line passing through point O and intersect AD and BC at points E and F, respectively. Prove that OE is equal to OF. Again, you would need to use the properties of parallelograms. Since ABCD is a parallelogram, DO is equal to BO and AD is parallel to BC. Therefore, angles ADE and ODE and OBF are equal. We also know, and since angles DOE and BOF are equal, we know that triangles DOE and BOF are congruent from the formula ASA, angle side angle. So OE is equal to OF. Discuss. In the above question, if line EF intersects the extension lines of sides DA and BC at points E and F as shown in figure 2, is the above conclusion still valid? Explain. Discuss. In the above question, if line EF is rotated around point O to the position in the figure number 3 below, is the above conclusion still valid? Conclusion. When a straight line is drawn through the intersection of the diagonals of a parallelogram and intersects a pair of opposite sides or the extension lines of opposite sides, and the resulting line segments are always equal, then it means that this straight line bisects the area of the parallelogram. Bisect means split it into two equal halves. So let's do a practice problem. As shown, the diagonals of parallelogram ABCD, AC and BD intersect at O. The straight line passing through point O intersects at AD and BC at points E and F respectively. It is known that the area of ABCD is 12 square centimeters. The area of the shaded part in the figure would be blank. I want you to pause the video and try to solve on your own. If you got 6 centimeters squared as your answer, you would be correct. Class summary. Parallelograms. Today we learned all about the properties of diagonals in parallelograms, which leads us to the conclusion that diagonals bisect each other. Today we explored and mastered the properties of the diagonals of parallelograms. We also used the properties of parallelograms to flexibly reason and calculate. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.